All right, so welcome to the second part of Physics, Science and Engineering. Those of you who don't remember me or who came here for the first time, my name is Jerzy Wrobel, and I will be helping you to learn this material. Now, you probably notice here an extra crew. This course now is going to be offered simultaneously in the class and on the internet. There are students who cannot attend the class, just few of them, so they will be watching it on YouTube. Actually, you have access to this course on YouTube too. UMKC has a special site, and it will be uploaded there every day after the lecture. So I'm not sure if you will be able to see it today, but definitely tomorrow. Because of that, actually, I modified the syllabus in such a way that I can accommodate both courses. And now, no matter if you on the internet course or the regular course, I recommend that you come to the class if you can. So maybe once or twice a day, those who cannot come on a regular basis, those who can come on a regular basis, please come, because direct interaction is more beneficial than watching it on the screen of a computer. Well, at least this is how I feel. If you feel different way, that's fine. I hope to have some audience, because it would be really awkward for me to speak just to the camera. So please, at least some of you, I would like to see some of you so that I can talk. Now, when you are in the class, you can actually participate in. You can ask questions. You can make comments. When you are in front of a computer, you will be only passive receiver of that information. Now there is one more legal point, because it will be on the internet, so it becomes public domain. So if you do not wish accidentally to be on the internet, identify yourself that you don't want to be recorded. And in this case, maybe you would better that you sit down somewhere behind the camera, so it will be very uncomfortable for the operator to turn the camera and point it at you. So is here anybody who doesn't wish to be recorded on the internet, on YouTube? All right, I assume that you have no objection, so occasionally one of you can get there. All right. Now, I advise that you mark this website on your browser, on your computer, no matter actually if you are an internet student or regular student, because it's also a way of communication between me and you. Among others, you have a link here to the syllabus. So let's review quickly what are the rules in this, because the syllabus is the arrangement between me and you. And useful information is also included on the syllabus. So, for example, you have here information how to contact me. Where's my room, my telephone number, my email address. Also, you have information how to access the page which you just saw a moment ago. You can visit me in my office. I have regular office hours on Monday and Thursday from 9 to 10. However, you will be also welcome if you come by making an appointment with me. Objective of this course is very similar to objective of Physics 1. to reinforce abstract thinking. This is actually the most important part of the course, that you develop a certain way of thinking. You have to develop a particular precision which you will need later on in engineering. You will have to enrich technical vocabulary. And in the class, I'm trying actually at this, well, at least until you comprehend or grasp the language, this technical language properly, I prefer that you do not use slang, technical slang, because some of you heard various technical terms and you use them. Well, to learn to describe and analyze aspects of nature, this is most mathematical part. You will have to have a particular background in calculus in order to understand. Well, and finally, there are some particular aspects of nature, and electromagnetism and optics are the subjects of physics 2. We are going to use the same book as in physics 1. It's the 7th edition of Physics for Scientists and Engineers by survey. The material will cover electricity, electromagnetism, wave and geometrical optics, and that's it. And the material this material is mandatory, no matter if it is presented in the class or not. I will not, if something is not presented in the class, I will not test you on that. However, if you go to the more advanced sessions, you will it will be assumed that you know that. The same way as I assume that you know calculus when you participate in this class. Now, for each discuss, I'm assigning now the homework, and every problem which is marked in a box at the end of the chapter is the subject of your homework. I want you to solve at least all the problems which are boxed. I advise you actually to solve even more problems. I had students who solved all the problems. However, I do not collect, and you don't get credit for solving those. In order to, I want to give you some credit for doing homework, so there will be also assigned homework, which you have to turn back. And I will assign homework every Monday, including today, and it will be due next Monday. Now, it has to be prepared in a particular way. It has to be prepared like a report prepared by an engineer to another firm, or like a proposal prepared by an engineering firm to a customer. On the link where the homework is assigned, you can find the instructions, an example how to solve it. However, it has to include comments. It has to describe the situation in the problem, justification of the steps, and justification. I use formula and write formula is not good. You have to identify what is the name of the formula and why is it applicable. All right. Now we will have quizzes. However, if you look at the grade, now this is the grade composition. We will have only 4 tests rather than 5. Each test will be worth 10%, so tests will contribute 40% to the grade. 20% of the grade will come from the lab, 20% from homework, and final examination will also contribute 20%. Now these are mandatory items. Now for the quizzes, I thought that this will be an encouragement for you to come to the class. It will be extra credit. So it won't be counted into the average. It is extra credit. So in principle, with the extra credit, you could theoretically collect 120%, although I would give only 100. Right, so we will have those quizzes at the beginning of each class, and I think that the quiz, I thought about that to it even before the recording starts. The students on the internet will not have to wait 5 minutes until you complete the quiz. We will flip a coin if you want to write a quiz or not, and it will always refer to the previous lecture. Concepts and definitions which were discussed on the previous lecture will be the subject of the quiz. And the grades will be, if it is perfect or very good answer, it will be 100%. For a good idea, it will be 70%, 30% for a vague idea with no significant errors, and no answer or a major error will qualify for 0. The test will be on September 10th, October 8th, November 5th, and December 7th. We'll still have a lecture on December 8th, and I think that at that time we will just summarize what we learned over the entire year. Here is the grade scale. Actually, I stretch it compared to many other instructors. Well, that way it helps you actually to get a good grade even if you mess up, let's say, one test. It's easier to recover when the grade scale is stretched. You have to obey certain rules of conduct. It has never happened in my lecture, and I hope that it won't happen, but in the case of academic dishonesty, I'm obligated to report the matter to the primary administrative officer at UMKC. The final note, I don't want you to use telephones, CD players, iPods, so that you multitasking, you listen to music on one side and listen to lecture on the other side, or surf internet on one side and listen music on the other side. I don't want you to use electronic devices during the session. You should spend approximately 2 hours studying outside of the class for 1 hour of session. And last thing, I advise that you read the textbook on a particular subject before you come to the class. I prepared the notes for you, and they are available at the bookstore. And well, if you didn't get it, most of you probably got them because you knew it from the first semester. At the heading of each item in those notes, the section in the book is identified. So if you flip a few pages forward, you can find out what subject I'm going to talk about the following day. Yes, Taya? What do you say? I'll try. However, because it is they are. The notes are on the internet. Yes, you don't have to buy them. All right, let's go there, actually. Here is lecture material. And if you click on this one, well, you have the notes. So if you want to have a in color, you don't have to buy it in the bookstore. I don't think that it's cheaper actually to print, but you will have in color. So what I was referring to is this number. This number over here says that it's chapter 31, section 7. Here are examples of tests. So when you are getting ready for the test, you may also look, well, these are some past tests. And here is a link to the homework assignment. So the first homework is due August 31st, and these 4 problems are assigned. Here you have a link to how it is supposed to be repaired. I mean, if you saw it last semester, it's exactly the same example. All right, are there any questions? Now, during those first minutes, I also noticed one more thing which I would like to ask you. If you come late, so the lecture is already being recorded, I will ask you so that you enter through the back door rather than through the front door, so that we are not an obstacle for the camera. Or if you want to sneak through this door, just sit down in front row rather than going to the end of the classroom. All right. So the first subject which we are going to discuss this semester, well, it's electrostatics, and the section of physics which deals with that is referred to as electromagnetism. And electromagnetism is a branch of physics that deals with interactions between objects related to particular attributes of matter. These attributes are charge and spin. And all phenomena associated with these 2 attributes also are included in electromagnetism. Now, I would like to start a certain discussion so that we review what attributes of objects we learned so far, which affect interaction, and what interaction have these attributes affect. So let's have a brief discussion. Talk to your neighbor. Now, if you don't know your neighbor, introduce yourself and get acquainted, because you will have to interact with each other quite a lot. Okay, so now talk to each other. I want to hear brainstorm. I got the question what we are supposed to discuss. Again, let me remind you. So run in your mind through the interactions which we discussed in Physics 1, which you learned in Physics 1. Can anybody give me a type of interaction which we discussed in Physics 1? A what? Impulse, for example. No, impulse is not a type of interaction, it's a physical quantity which describes interaction. Let's try another thing. Gravity. Correct. Gravity is, for example, an interaction. All right. And actually, this is the only interaction which refers to interaction between particles. So the attribute which I'm looking for is associated with gravity. But now, how about if we also review the interactions which we discussed in Physics 1 between objects? Friction, correct. Friction is also interaction. Tension, correct. Tension, or more general, any type of elastic interaction. So opposite to tension was compression or normal force, right? Normal force is the result from compression. I don't remember if what else did we discuss. Oh, what type of friction? Because we had different types of friction. Yes. Our drag is something else. Correct. Drag is another interaction. Yes. Static friction and kinetic friction. Correct. All right. Now I recall that we discussed few interactions with fluids. What? Viscosity is actually an attribute of a fluid which affects the interaction. Although I understand what you mean. I think I can accept it. Yeah, yeah, because drag is actually a consequence of viscosity, right? So when Vincent introduced included drag, viscosity is the same thing. It refers to a particular drag. Now, what allows plane to fly? Lift, correct. All right. So now the only from those which we listed, only one, gravity, was between particles, and which attributes now determines how particles interact. Attribute of a particle. A what? Mass, correct. Yeah, depending on this, how particle interact, appropriate mass is assigned to it, although it's kind of coincidence because mass was really introduced as an attribute which describes inertial property of objects. But by coincidence, nature made it that the same attribute which affects inertia, it affects also gravity. All right. Now I would like to demonstrate to you this the need for another attribute and evidence of another type of interactions which we have not discussed so far. Here I have some PVC tube and a piece of hair. And I see that there is a possibility of interaction, which I recognize that this is not an interaction which we know so far. Like, have you noticed the effect of interaction? All right. Now let me go ahead and make certain trick. Can you see the interaction? All right, now talk to each other why it's not gravity. Maybe it's gravity. Well, don't tell me that it's electricity because I haven't heard about electricity. Yeah. If we recognize that it's gravity, we will actually rewrite the books and deny existence to electricity. We failed to do that, though. Talk to each other why it's not gravity. Anybody has an argument? Yes. Actually, you phrase it. Don't use slang. Yeah, I know what you mean. Gravity is affected by mass of objects, right? I mean, we don't have mass. It's not some kind of matter which is inserted into objects. Objects have mass, like we have age, for example, right? But it isn't some kind of substance which we put in. So interaction with an abstract object, the abstract concept cannot exist. Mass is a concept; it's not an object. This is what. But I understand what you meant. What he meant is that mass of an object affects gravitational interaction. Yes, that's great. So what?
The interaction between the fur and the...
Yeah, that, I mean, when I was doing this, right?
Right. It only spun after the interaction between the fur and the pipe.
Right, but this is still not convincing. I mean, actually, we didn't test it, but your intuition probably says something about these two objects. By rubbing these two objects, I failed to do something which caused gravitational interaction. Yeah, because, I mean, maybe there was a weak interaction before I rubbed, right? And then I rubbed so that it did not cause any effect. Now then I rub one end, I change the attributes of these objects so that suddenly gravity became strong. What would I have to change? Mass of what? Of both objects. What would I have to do with the mass of both objects? Increase. By rubbing, I would have to increase mass of this object and mass of this object. Well, or at least one. And actually, I would have to do it by a lot. Right? Now, we don't have a scale over here to test it, but who of you believes that I did change mass of those two objects? Who doesn't believe that I changed mass of those two objects? You are right, I did it. Right? By rubbing, I try rub the hand of your neighbor and see how your mass is going to increase. Now there's one more thing. I mean, let's see if I rub this and see how his head is getting to this one. Well, it isn't. Yeah, gravity didn't. Well, this is a good argument for excluding gravity from the interaction. Now, well, actually, I will show you another argument. I think I have to take this one. No. Here you can see another argument that it's not gravity. What is it? It's repulsive interaction or repulsive force. Although force is a physical quantity which describes interaction, so it's better to say that it's repulsive interaction. Right? Correct. Gravity is always attractive. This one is repulsive. And actually you can see something which we'll discuss later. Now, if this attracts, these two attract too. Now, if these two attract, this repels and this attracts. We'll figure out later on how well, why those things happen. All right. Well, so we see that there is another interaction, and well, we'll also soon find one more interaction referred closely related to this, however, related as magnetic interaction, and all of them, both, and so entire electromagnetism actually is described by equations, well, put together by James Maxwell. He was a Scottish scientist living in 19th century, and all electric and magnetic phenomena are based just on 4 equations which he picked. He was not author of all of them. He is author of, well, partially in one of them. However, because he put them together, they are referred to as Maxwell's equations, and there are 4 of them. In a free space, these 4 equations describe how nature behaves. The first one, this one is called Gauss's law for electric fields. This one is referred to as Gauss's law for magnetic fields. This one is called Faraday's law of induction, and this one is called Ampere-Maxwell law. I know that at this point is gibberish, but at least let's learn how to read them. And I think that this will be all for today. When we learn how to read them, and comprehend actually what is done. Probably let's start with Faraday's law of induction, because this one is, well, at least we are familiar with notations. E is a certain vector, which we will discuss tomorrow. It's referred to as electric field vector. And in this integral, we multiply electric field vector by differential, how did we describe that? Differential fragment of a path vector. I think this would be the best phrase. Now, it is that if I imagine a line, how about if I make a drawing on the whiteboard? If I imagine a line, it could be a path of something, or just arbitrary line which I imagine in space. I have to divide in order to get this vector ds. It's one of the tiny vectors assigned to a tiny fragment of that line. So if I divide it into pieces, I can now make a vector over here whose magnitude is equal to the length of the fragment of that line, and the orientation is consistent with, is parallel to the line and consistent with our decision which way actually we want to integrate. So for example, if I want to integrate from point A to B, I divide this line into small segments, and to each segment I assign a vector whose magnitude is equal to the length of the segment, and it's parallel to the line from the initial point to that final point. All right. So if we look at this expression over here, we recognize that we multiply electric field vector with that segment vector. how? Let's review our how we know what we know about multiplication, how we can multiply. Can we recall what we can multiply? Number times number. Is this the product? Is this the product of number and number? No. Which one? Yeah, we have vector times vector. We know how to multiply vector times vector in two different ways, right? What are they? Cross product and dot product. Correct. What's the difference between cross product and dot product? It's what we get. What is the result? If we use cross product and multiply two vectors, the result is going to be a vector. If we multiply two vectors using dot product or scalar product, we get a number. Correct. All right. So we understand what we multiply here. Who doesn't understand how to what is happening here? Well, what product is here? I mean, what of those four products? Yeah, because right now we know four multiplications. We haven't finished. We haven't actually listed the fourth one. What was the fourth one? Number times vector. Correct. Now this one is vector times vector, but since we have two, we have to identify which vector, which product. Cross product? Dot product? Who votes for dot product? Who votes for cross product? Those who voted for dot product, it's correct. The result over here is a number. Now that symbol S, what that symbol S represents? An integral, correct. And now I want you to think about an integral that it's a sum. So here we are adding products. If we imagine a line, like this one over here, then for each of those segments, I mean, in order to evaluate this integral, for each of those segments, electric field vector has a particular value. So at each point I multiply the vector, the two vectors. Here I multiply the two vectors. Here I multiply the two vectors, and so on. So all segments of the line. And then that S, which is the symbol for integration, means that I have to add all those products. Now there is a circle on this S which we are not familiar with. It is a definite integral. All four integrals are definite integrals. Now in definite integrals, you remember that we always specified the limits. Now if we put a circle on that S symbol, it means that we have to choose a particular geometrical object. Now in this case, it has to be a closed loop. So that the line has to end at the original point. So the circle means that when we integrate over a loop. Now, if we didn't have a circle, so if it was not over a loop, also over a loop, I mean, we were capable to do it over a loop as well, and there was a particular case in which we thought about integration over a loop. But if it were not, if we just had integral of E times ds from point A to point B, how would we call that integral? Consult with each other. We had it already, and recall actually what quantity in the past we integrated. Actually, that integral also is a physical quantity quite common. Let me give you a hint. It describes also interaction. Did we integrate something in physics 1. We use different letters. Actually, only one letter. Instead of E, we had a different letter, but we had the S. What was that? Force. Yeah, we integrated force, so we had F times ds. What was that integral called? Work. Thea is right. That integral was work. That work is integral, the same type of integral of force. Now, if we integrate actually scalar product of a certain vector with multiplied using scalar product with segment vector, that integral in math has also a negative. Why? What do we call it? What do we call an in general integral of such a scalar product? It's referred, I think that in Calc 3, only those who had Calc 3 can answer that question. Or if you had physics 1 with me, you could also answer the question if you remember what I said. No, it's not an equation yet. No, because integral equation requires equal sign. I'm asking only about the left-hand side of this equation. Well, it's called a line integral. So whenever you have scalar product of a vector and segment vector and integrate that, it's a line integral. So here is line integral over a closed loop. A closed loop is also referred to as Amperian loop. So now explain to your neighbor what we calculate. Use these new phrases to tell the neighbor what we have on the left-hand side of that equation. And don't use letters. Actually, more specifically on the All right, here I have a suggestion which trying to make sense. Why don't you now read the left-hand side?
The field multiplied or the dot product of the position over the line shape, over the geometric shape, the line and also the...
I think you will confuse that. I mean, you said it better when you was talking to me. I know that you got very excited now. Can anybody try to phrase it? Yes, go ahead.
The line integral over closed loop of the result of the scalar product of the electric field vector and the segment vector.
Who likes it? Who doesn't like it? Okay, can you fix it? I like it too, although I must say that there was redundancy in it. There were too many words in that phrase. What was redundant? Closed loop was not redundant. Yes?
When I said the result of the scalar product of the scalar.
Right, that is redundant. Why? Because he said it earlier. How?
He says a scalar product and then...
Yeah, that scalar product, when he started to talk about scalar product, it was already redundancy. Why? Because he said line integral.
Oh.
Yeah, so when he said line integral, it immediately means that it's that scalar product. Right, so, Thea, can you phrase it neatly now?
Well, I see how I
Sure.
I have the sum of all of the scalar products of the electromagnetic field times the segment.
Electric field.
Electric field.
Uh-huh.
Times the segment vector on closed loop.
I buy that. Yeah, this is correct too. And actually, it is pretty neat. It is concise. However, I want you to learn my way too. I mean, it's correct. Yes, say it.
The change in S and the change in the electric vector.
Why change?
Okay, I say change in S because as we're moving from point to point, small, minute changes.
But we are adding them. Yes, so this
Right,
is,
but that's always going to be the same value,
sums and
the same magnitude.
Uh-huh.
So if you take that same value and you add them all up, it's going to be a line integral.
I understand that. I cannot say that I'm impressed with by the phrase. It is a little bit complicated. You could confuse. I mean, if you talk to somebody who understands it, who knows the subject, they will get it. So I got it. But if you're trying to explain it to somebody who is learning it, he or she would get confused. Yes?
Can I fix mine?
Sure.
Okay. A line integral of the closed loop of the electric field vector and the segment vector.
You don't even have to say that segment vector, because line integral requires that we multiply it by the segment vector. Correct. So it is line integral of electric field vector over closed loop. All right. Now on the right-hand side, we have an expression which, if we knew what that phi sub b represented, how would we read the right-hand side? Now let's start with this equals minus. How we read equals minus? Obviously, I don't want you to read equal minus, right? We would have to say that the line integral and blah 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 to the right hand side. What would be that blah blah blah? Is opposite. It's perfect. It's opposite. I don't like actually if you say it's negative, because we don't know what is negative. Minus in front of minus 2 actually means that it's positive. All right. Now here we have derivative with respect to time. So we would read this as it's too complicated. A what? Rate of change, correct. So line integral of electric field over a closed loop is opposite to the rate of change and instance of magnetic flux through the surface spanned by that loop. All right, so this will be all for today. See you tomorrow. Let me remind you again that if you come late, please come through the back door or sneak in such a way that you do not interfere with the camera. Thank you and see you tomorrow.